Welcome to students. Today our topic is queuing theory. It comes under the module 6 of operation research in Mechpro syllabus. So basically queuing theory, they are saying it as a waiting line. You can find in the syllabus they are given as waiting line problem. Okay, so don't get confused. This waiting line problem are nothing but the queuing theory itself. So let us start with some basic introduction, backgrounds, examples. What does these things queuing theory or what does this waiting line problems generally deal with? So in the introduction part, I can tell you, you already are accustomed with the term queue. Queue means it is a waiting line. You already faced waiting or making a queue in going to a bank, in barber shop, in ration shops, in cinemas counters. You already know what is a queue. So basically we are dealing with that particular queue only in this particular topic known as the queuing theory or waiting line problems. Now coming to the introduction part, I can tell you how the queue is formed. Okay, the formation of queues or waiting lines is a most common phenomenon in our everyday life. So it occurs where the current demand, the first one is the current demand exceeds the current capacity to provide that service. And queues are also formed even when the service rate, you can see over here, service rate is higher than the arrival rate due to a random pattern of arrival of customer. Due to random pattern of arrival of customer, you can also see. So there are mainly two main reasons behind the formation of queue. One, the current demand when exceeds the capacity, or being, you can say, capacity means here the service. We are not able to produce service or provide service according to the current demand. Then the queue is formed. Okay, so let me give you a diagram of queue. You can say these are the customers or units, whatever you can say. And one more thing I would like to say you that queue can be a living beings or non-living beings also. How is that possible? Living beings, customers or human beings, you can say. For non-living beings, you can say as the machines, the tools. Okay, so we are dealing with both the living beings queue and the non-living beings, that is the machines queue also in this particular queuing theory. Now next, the examples I can say real life examples. I have written over some examples, common examples. You have also faced the barber shops, ration shop, cinema ticket window, bus stop, bank counters, railway reservation, metro reservation. Nowadays in Kolkata you are facing you have to make a queue during catching a bus, having a auto rickshaw. Okay, so these are daily life phenomena. This queue you already know. Telephone booths nowadays these are obsolete as we are all having mobile phones. So telephone booths nowadays you can say it is obsolete one. Doctor's clinic, you already has faced, I think most of you. And doctor's clinics, they are going to have a long length of queue. Now these are the real life examples. Now coming to the manufacturing industry. As an engineer, you have to know this also. In manufacturing industry, what happens? In process goods wait for next operation or waits for getting moved to another places. Okay, in manufacturing industry. And machines, you can say also machines. This one is a machine, M/C. I have written in short form. This depicts the machines. So you can say machine waiting for repair parts or components waiting for assembly in assembly lines also. And you can also say the blunt tools are waiting to be regrind. Okay, this need to be regrind. They are waiting for being to be regrind. So you can see these are the examples of queuing theory, or you can say the queues. So coming to the next part. So what does this I mean to say, what does this signifies? I mean, what is the problem of this queues? The problem is that this may increase production cycle duration. I am talking about particular this particular thing. Okay, manufacturing industry, you can say this may increase production cycle duration, which adds to the cost of the product, and it may also delay the specified delivery period. So obviously company has to suffer the loss, and profit will be minimized. So this is the main problem, and we are dealing with it as an engineer. Okay, now you can say queues, types of queues. In types of queue, you can say queues may not be a physical line of customers, as I already said. There can be a machine or anything object, you can say. It may be a merely a list of customers. Okay, here I have written over it. It may be a list of customers, or you can say units, or you can say orders, likewise, etc. Now some examples I can tell you, specified examples of this particular type of queue. Types of queue is the unconnected telephone calls, you can say, and waiting list of passengers for a berth. Okay, you already faced, I think most of you have faced this problem, waiting line of passenger for a berth, and unscheduled orders in different departments, you can say, untyped paper with the typist, etc. and else. Okay, so these are the types of queues. Now what is our aim? That is the main thing. What is our aim? Our aim is to decide the best level of service the organization should provide. Okay, now if you say I can handle or I can provide much more service, but providing too much service would involve excessive cost. On the other hand, inadequate service would result in long waiting lines, which results in dissatisfaction of customers, or sometimes loss of customers due to the bad reputation of the particular organization, or company, or service sector, you can say. Okay, so our aim will be, as I already told you, this particular subject OR is dealing with the optimization. So our aim will be to decide the best level of service the organization should provide. That is our aim. So now, how to fulfill that particular aim? We have to, the ultimate goal. Next comes the ultimate goal. Okay. So our ultimate goal is to achieve an economic balance. Economic balance. As an engineer or a manager, you need to optimize, okay, between the cost and the quality. I already said in the introduction part. You always have to keep in mind that you have to keep a balance, okay, between the quality, or or the service, or and between service and the cost, or you can say in between the quality and the cost. So our ultimate goal is to achieve an economic balance, that is optimization between the cost of service. This one is between. I have written sort way. B/W means between. To achieve an economic balance between the cost of service and cost associated with waiting for that particular service. So that is our ultimate goal, to maintain an economic balance. Okay. Now, how we approach to that solution? Coming to the approach of the solution, I can say these are the particular alternatives we have in our hand. What are these? You can see the first alternative says you can provide more facilities, but you have to incur additional cost. Okay, the next one says replacing less effective or efficient service facilities with the efficient ones. That would also have some additional cost. Next says changing the pattern of providing service. That will be a difficult one also, but you can change. I am not saying that you cannot change the pattern of providing service. You can change. Okay, so the next one is the changing the pattern of arrival of customers. This one is also difficult, but I am not saying you cannot change the pattern of arrival of customers. And the last one says effecting method improvements to reduce service time. That is the most important one, and we are dealing with this one only in this particular queuing theory subject, or you can say waiting line problem. So effective method improvements, okay, to reduce service time. So I think this is the basic introduction to this particular subject, queuing theory. So in the previous video we already learned about some background of queuing system, or you can say why we are solving this particular type of waiting line problems. We have also discussed the different types of queues, some real life examples, and what is our aim. So today we are going to have some basic concept on the formation of the different models we are going to solve in our next videos. So particularly this topic you can tell it as elements of queuing system. So what is a queue? A queue is basically the waiting line of a human being, you can say, or also you can say some components. Okay, maybe you can say it a machinery or tools for regrind, whatever you can say. So it can be a living being or it can be a non-living being also. So without a queue, there is no meaning of solving waiting line problem. So queue is basically the you can say the main thing in a waiting line problem. So we are dealing with queue. So you can see over here, this is a typical, you can say, a system of a queuing system, you can say. So in this particular queuing system, you can see over here, you have got an input source, then comes the queuing process, then comes the service mechanism. In this input source, we have you can say its size. Basically I can write it over here. It depends on the size, and the second thing, the pattern of arrival. So from the input source we can say the size of the queue, okay, whether it is a queue of a human being, that is the living, or the non-living ones, that is the machines or the tools, whatever you say. Now generally in input service we use the term as customers, whether it is a generally in case of a living being we are using the term as customers. So the customers requiring service are generated over time by an input source, you can say. These customers when entering the queuing system and join the queue. Okay, next at certain times a number of the queue is selected for service. This is the queuing system and this is the service mechanism. Okay, it is the arrival process, and these are the waiting customers in a queuing, particular queuing particular queue, you can say. Okay, next is the service mechanism. So the required service is then performed after you are standing in a particular queue. So you can say at certain times a number of member of the queue is selected for service by some rule known as this, I have written over as queue discipline. Okay, then the required service is then provided by the service mechanism. after which the customer leaves the particular queuing system. Okay. So this is basically a typical system of waiting line, or you can say it is a of queuing system. Okay. So next, let us discuss some of the various elements in relation to the queuing system. First of all, you can say it is a input source. We already defined what is input source. They also sometimes call it as a population. Okay, in later videos when we will be solving numerical problems of different models of queuing system, we will be calling this as a population. Okay. Next we have whatever line, waiting line. That is the main thing, the key thing in this particular module or chapter. You can say this is a queue. Queue is the main thing we are dealing with. Next is the service discipline, as I already told. Then is the service mechanism, then is the system output, and next is the customer behavior. Now the customer behavior, we have to learn some terms over here. I will discuss it later. Some of the terms are ranging, bulking, okay, jockeying. So coming to this particular input source, I would like to say some more words. The size is the total number of customers. Okay, you can already know from the name size itself, it is the total number of customers that might require service from time to time. That is the size. The size of the input service is generally assumed to be infinite. We don't know the size, so we take it as a infinite. Okay. Now the railway reservation system, tax toll, both on highway, etc., are the examples of infinite, you can say, queuing. Next, the arrival. The arrival of the customers may either be a constant or a random. We don't know. Okay. Arrival. Most arrivals in a service are of random time. You don't know whether it is going to be a random or in a certain pattern, but we assume to be a random. Next, you can say this is when each arrival is independent of previous arrivals. Okay, that is the random one. The exact prediction of this particular random type of system is not possible. So the number of arrivals per unit time, that is the most important thing I am going to tell you. The number of arrivals per unit time, that is the rate of arrival. It is called as rate of arrival. Rate, you know, rate means involvement of time. Okay. So the number of arrivals per unit time, or you can say the rate of arrival, is estimated by, Poisson's distribution. It is estimated by Poisson's distribution, as we don't know the exact rate of arrival. So this is taken as Poisson's distribution. Now the mean arrival rate, that is one of the most important things I am going to tell you. Mean arrival rate, you can say, that is the average number of arrivals per unit time. It is known as mean arrival rate. Mean arrival rate. It is denoted by lambda. Okay. It is the most important thing. You must remember, we are going to use this particular term each and every numericals we are going to solve in our later classes. Okay. So this is the first most important term. Mean arrival rate. It is the average number of arrivals. Okay. Average number of arrivals per unit time, and it is denoted by lambda. Okay. The next one is the mean time between two consecutive arrivals. First arrival and second arrival. The time gap, or you can say the mean time. So next one is our mean time between This means between, okay, consecutive arrivals. What is the mean time between the consecutive arrivals? That means the time elapsed between the first arrival and the next one. Say, and the next one. It is known as the mean time between consecutive arrivals, and it is equal to 1 by lambda. This is the most important two terms I have discussed with you right now. So keep in mind the two terms are, one is the mean arrival rate, or that is denoted by the lambda, and the second one is the mean time between consecutive arrivals, that is denoted by 1 by lambda.